Today I want to talk about running an emulated RISC-V environment under QEMU. The RISC-V CPU is a CPU architecture that I have a good amount of enthusiasm for. This is an open architecture CPU where the source for the CPU architecture is available to everyone. You can build your own RISC-V CPU in an FPGA, you can modify the instruction set, you can introduce new instructions, you can learn a lot about CPU architecture. Kind of just like Linux, where you can tinker with the bits that you want to tinker with. There are some ARM CPUs, some PowerPC CPUs, and others that have software implementations that you can tinker with. But I like the fact that the RISC-V architecture is intended to be open. To learn about the RISC-V architecture, there's a couple ways of doing it. One is to go out and buy a RISC-V CPU board. Another way I'm going to talk about is to use the Linux QEMU quick emulator to run a virtual CPU and emulate the Sci-Fi Unmatched board. The Sci-Fi Unmatched board is one of the popular and available RISC-V boards, and it's kind of like the Raspberry Pi of RISC-V. So there's a large number of Linux distributions that do support RISC-V. But on the Sci-Fi website, they have support for both CentOS and Ubuntu. I picked Ubuntu somewhat randomly, but I feel like Ubuntu has had a pretty good success in supporting embedded boards like the Raspberry Pi. To get started, I wanted a Ubuntu development environment. I'm going to use Ubuntu 22.04 long-term support LTS as a host environment and as a target environment. My thinking is keeping it all one flavor of Linux gives us a better chance of success. So the main Ubuntu site will take you to the desktop download and the download for Ubuntu 22.04 LTS, which currently is the most recent long-term support version of Ubuntu that's out there. So I'm going to use Qubes to create my Ubuntu environment. I like to use VMs to create whatever version of Linux that I'm working on at the time. I want a standalone hardware virtual machine, not one based on templates. Templates would create some more complication into building up the environment. You don't have to do this way. You don't have to do this under Qubes. You just install Ubuntu natively on a machine or any other virtual manager environment like VMware, VirtualBox, KVM, Zen, EXSI, etc. So I've downloaded already the Ubuntu 22.04 long-term support for the host, for the hardware VM. I had to download it into a new Qube because my default environment doesn't have enough space to handle the whole 3-point-some-odd gigabyte virtual image. So the unfortunate part about this is setting up an HVM is a little bit of a dance. Qubes does have a good web page that's pretty succinct on how to create an HVM and how to get the OS installed. And we're going to use the GUI version of that. We're going to use each one of these has in the GUI manager. We're going to use that GUI manager portion of the environment. So we're going to go to Qubes Tools, create Qubes VM. I'm going to call this VM Ubuntu, and the type, I'm going to make it a fully persistent standalone version. The template is going to be none. And here's one of the places where we get into kind of a little bug, I think, because we want to launch the settings after creation, but before we boot. And we really want to install from a device, you know, from a, doesn't have to be a device, but it is a, appears to be a device to the VM. But if you notice, once I click Install System from Device, it unclicked for me Launch Settings After Creation. And the inverse. This seems like a little bit of a bug. So I'm going to leave the default networking as sysfirewall. We're going to patch that up later. But here we go. We'll create a new cube. Okay. So we're going to call it Ubuntu, no template, sysfirewall is what we want. Here's some of the information here in the net cube. It's already allocated an IP address for this new cube. I want a good bit more space because we're going to have to download development tools and download a bunch of stuff that's going to run out of that little 2 gig real quickly. All right, so here again, I just don't want to fight with memory, so I'm going to start with 4 gigabytes right away. 2 CPUs is okay. I am going, let's see if there's anything else. We are in HVM mode. It quietly switched the mnemonics on us. Before it said standalone persistent, now it's saying hardware VM, which is what we want. So I am going to boot from a file in a cube, and that cube is going to be the temporary one I created with enough space, and I'll just browse for the ISO in that cube, and I'll hit OK there. And we're off and creating our new cube. All right, and we'll try or install. Maybe I should give it more CPUs. All right, I'm going to pause here just for a second while this thing gets itself up and going. I'm running this on a slower machine. So I do a lot of experiments on my non-daily drivers. That way I can leave my daily drivers alone. I have a faster machine that I've already done this on. So forgive me while I get these pregnant pauses. There we go. Actually, there we go. So now in our hardware VM, we are booting Ubuntu. And it's going to give us the standard setup stuff where we need to set up our keyboard and our time zone and a few other things. Things that both Linux and Windows have never really learned to automate. I don't know. Does Windows auto detect the keyboard? I don't think so. I'll have to look. I'll have to check that. But at least in Linux, there's a few things that Linux has never learned to auto-determine. And maybe it's not possible, but it has never learned to auto-determine the keyboard type. It always seems to prompt you for your time zone. So here we are. Here we go. We should get our nice little Ubuntu setup environment. Actually, yep, here we go. So we're going to install Ubuntu, and we're going to install it in English. English keyboard, English US. Normal installation. I'm just going to let that go. Right now, it does not have a network connection. Erase and install. So, if I was doing a Ubuntu for a native machine, I would probably either use the LVM, Logical Volume Manager, or ZFS, and I would encrypt the operating system. But here, it's already a encrypted volume that is running the VM, and this is kind of like a throwaway development environment anyhow. So we're just going to select no advanced features, and we're going to let it erase and install. And I bet I didn't give it, I don't remember. Yeah, that's probably good enough. Let's see if it'll go. Yeah, 21 gig. I kind of wish I would have given it more, but we'll go with this. Yep, I'm gonna let it play with it. Tell us we're in the New York Times. My name is going to be user. My computer's name is going to be Ubuntu. User. Yes, it is a weak password. off we go to installing. I think I better pause for a moment and let this continue. It's going to be slow and kind of boring. So we're getting to what I hope is the end of the Ubuntu installation within the hardware. Yep, okay, there we go. All right, it got to the end. So we're going to click restart now, but the hardware VM is going to shut down. This is an aspect of Qubes. I'll just let it shut down. It's okay. No, it didn't. Oh, yes, yeah, we do have to shut it down. We do have to shut it down because we've got that virtual CD-ROM installed in the VM. So we'll go to the Qubes manager and we'll just kill. Yes. Kill is a hard shutdown. I'm going to check in the settings that I don't have a CD-ROM installed any longer. Yeah. All right. So we'll go back to that. And we'll just start it again. That'll be our reboot to finish the installation of Ubuntu. So again, this is creating the Ubuntu host environment that we're then going to use to run QEMU. You could certainly, and I think a lot of people would, rather than the way I'm doing it. I like VMs because you can do something and you can just throw it away. You know, it's like, oh, that was a bad idea. I'm going to try it a different way. And so I am creating a Ubuntu VM, hardware VM on Qubes, just so I can have a host environment, a Ubuntu host environment for QEMU. Did I type it wrong? Hello, computer. There we go. All right, let's get. I don't want to send anything right now. I don't care about location on this. We're ready to go. All right, we are done. All right, I'm gonna change the display settings to give us a little bit better resolution on the display. I'm not going to worry about installing the VirtIO drivers correctly so that I could just dynamically resize the display. I'll just leave it like it is, where I have a few hard-coded resolutions that I can tolerate or use. All right, so the other problem is if you notice, we don't really have any network connection. So we're going to go to why did it not take me to the network? Network. Clear at the top. It says connecting, but it's going to fail. So this is one of the problems with Qubes-OS in hardware VMs. So we don't have any of the Qubes tools installed in order to know what our IP addresses and such are dynamically set at. So what we're going to do is we're going to go into settings, because it has already allocated the IP address it expects for this cube, and we're just going to manually add that one in. So 10.137.0.19, 255.255.255.255, and that net mask, I'm not sure how that works, but we're gonna use it, because 255.255.255 says I'm only gonna let you have just one IP address, and we've determined that IP address is 10.137.0.19. So how does it get to the gateway? Well, I don't know, but I'll have to go to get that one a bit. 138.7.158, and I want DNS 10.139.1.1 and 10.139.1.2, and I don't want it to be automatic. And I think that's all I need here. I'm going to apply it, but this is not going to help. This is probably going to still be, oh, it is up and going. Look at that. All right, let's see if we can ping. Puff. There we go. It is, the network is up and going. So now, first thing you do whenever you install Ubuntu is go out and make sure it's up to date. So I'm going to do app update, apt upgrade, apt auto remove. This is kind of my standard. Just get it up to date and show me what I need to remove from old packages and so forth. Gonna take a minute because it's going to have a lot to update, but I always just want to get back to the latest stuff whenever I install a machine. Yes. All right, that's going to cook for a minute. So Ubuntu has a wiki page for the RISC-V stuff. How do you go about booting and installing it? There's going to be a problem, though, or at least I ran into a problem. It says to install QEMU, Uboot QEMU, and OpenSBI from the regular app utils. This didn't work for me, and I found other people that were having the same problem. They're having a problem where it just comes up and panics. So we're going to actually compile a specific version of Uboot and compile OpenSBI and use that to bring up QEMU with the virtual RISC-V processor. It's doing pretty good. Doing pretty good. So I noticed it just installed Snapd. Ubuntu is now using Snapd for Firefox, which is interesting. It's probably a good thing. All right, I'm gonna pause again because it's gonna be just sitting here watching all the packages install. And we're coming to the end of the first update. We kind of expect, you know, if we download the ISO and we do a clean update, we shouldn't have any problems. This is another reason why I like VMs, is like if you've played with the environment too much, you know, you've installed your own Python that's in your path and so forth, and how does that affect things? I had a big problem with Pedal Linux, and I needed a version of Python, and keeping Python out of the way, I eventually had to go to the Python and virtual environment stuff. But this is one of the reasons I like VMs, is if things get too messy, just throw them away and start over again. But all right, so we've got a up-to-date version of Python that we fresh install and a full update. Now the next piece I'm going to do is I'm going to install Git, because I need Git to get to my script to do QEMU. So running QEMU was not as clean as I would like it to have been. You know, if these instructions would have worked, I'd probably just do them manually right now, but they didn't. And the problem I ran into was U-boot would panic, and I was using the default U-boot, and I found someone else who was having a similar problem. Let's see. Yeah. And I found someone called XYPron. He said, this works for me, and he described how to go get a version of U-boot, the Git repo for the U-boot, and reset it to a very specific version, and build that version, and then build Open SBI, which is for RISC-V, and then boot with that, and that works. So just going to kind of follow his lead, and I've stuck the knowledge. Oh, I got to restart. And we'll just shut down. We're going to shut down because sometimes Qubes behaves better than if you do reboots. So we're just going to start him back up. Ubuntu start Qube. And we've looked at our IP addresses, so we shouldn't need that. Should give it more than 2 CPUs. It is slow. Okay. See if we can get a bigger terminal. Heck with it. I'm just going to go with it. So now we're going to go get my script. github.com/edt11x. That's me, Ed Thompson. 11x is a number I used to use for racing, and it's going to be EDT RISC-V. I usually prepend a 3-character name on lots of things, on variables, on subroutines, just so I know there's no name collisions. It's my cheap way of avoiding name collisions. All right. Oh, let's go to that repo just so we can see the README real quick. Hello, computer. It's thinking. I don't think I have GVim. I have Vim. Yeah, that's fine. Me? What did I do? Maybe you can't go straight to the project. Oh. Helps if you type the right thing. EDT 11x. There we go. So, you know, there's just a couple of scripts in this repository. One called Do It that will download, again, 2204, but for the unmatched RISC-V embedded board. And then it'll get U-boot and open SPI and compile it, and also install the developer tools that are needed. And it will try to do everything and then run it. And so we'll look at Do It here real quick, because so I originally started with an older version of Ubuntu, so I made these variables, and interestingly they changed the location of the releases. So I made that a variable too. This is just a cheap script. So if it doesn't find the image.xz file for the Sci-Fi unmatched board for Ubuntu 22.04, it'll go get it, wget it. And then we'll unxz the thing, but we'll keep, -k, keep the original, because I want to be able to just throw away the, you know, after I've modified the images and stuff like that, I want to be able to just throw away the image and go back to something sane. So we want to install the RISC-V GCC tool chains, we want to install a bunch of standard Linux build tools. And we want to install OpenSSL. This one was actually given, these set of tools were actually given in one of the web pages. I think it is this guy, our prerequisites somewhere. Now, anyhow, there is a list of prerequisites. I just stuck them in here. Like my business partner likes to say, our documentation is like your documentation, except ours compiles. So the knowledge of what I need to install is just stuck into this script. And you can see we get the GCC toolchain, a bunch of the developer tools for Linux, and I found out that to compile U-boot and OpenSPI, I needed the libSSL developer library, so I installed OpenSSL and libSSL develop. And I also need the QEMU system MISC to boot the RISC-V CPU. So we've downloaded, here we downloaded the Ubuntu 22.04 for the RISC-V CPU. And like I said before, Ubuntu has a wiki page about this. And here we see a release directory for the Sci-Fi board. And the unmatched image, they had an older board called Unleashed, and now it's kind of deprecated, so they're just supporting the unmatched board. And we want the pre-installed images. So we're gonna unpack that, un-XZ it. We're gonna resize that image to give us some more space, and then it says next use OpenSPI bootloader and uboot.qemu. Well, what we're going to do is we're going to look for the firmware payload. And if it's not there, we're just going to go out and get uboot. We're going to reset to that specific version that we found works from another person trying to make this work. And then we're also going to clone and compile OpenSPI, and then we will try and boot the thing. And this is my command line. I've left a couple, everybody's got their own, this is what you need to boot it, and mine doesn't quite match any of them. It's just a combination of trying different things. But here it is, QEMU system machine vert. We're just going to use a gigabyte of memory, 2 cores, and we're going to let this whole thing boot. So now what we have to do is this is just the script we were looking at there, and we're going to run it. So there's do it and run it. Do it does the whole mess. Do it is kind of like my foobar for running scripts. You'll find that if I need to make a quick temporary name for an executable, it'll probably be called do it. And run it is just don't try and compile anything, just run the image you already have. So it's going to go out and it's going to get that version of 22.04 from Ubuntu from Ubuntu and just copy it down here so we have it. And then the next thing it'll do is it'll increase the size of that so that it's got some space. And I want some space so that I can do, like I talked about before, is the first thing you do is you update Linux to the latest, and make sure that that all works. And one of the reasons I'm using 2204, I did use the older long-term support. I think it's 2004 long-term support for this, and every time I tried to do that initial update, it would corrupt the system in a way that it wouldn't fully boot. So I was very happy to see when I tried it on 2204 that it did. I'm going to pause the video now because it's just downloading. I'll be back in a second. So we're coming to the end of the download. There we go. Yep. And then we unXZ the image, but I keep the original there because I want to be able to just wipe out the image if I've done something bad to it and just have another image there to start back up again. So, and then we're going to install the tool chain stuff. All the installs are going to go next. All the Linux tool installs. So we're installing this onto the Ubuntu host, even though the Ubuntu host is a VM. Installing all the tools, Linux tools that we need into the Ubuntu environment. And I should have combined these all into a single apt install, but I didn't. So we're unpacking and installing all the libs and flex and bison and autoconf and so forth. And I don't know if this is the optimal set of packages, but we know it is a set that will help. Like I say, I found out when I was compiling Open U-boot and OpenSBI that I needed libSSLDev. And now we are going to install the QEMU MISC stuff. Is that right? Yeah, QEMU system MISC. That's what that guy is installing. Okay, then we start cloning into U-boot. I'm going to pause this again. U-boot's pretty big because it supports so many different environments and boards and stuff. It is really pretty big. So I'm going to pause it for a minute while it downloads the U-boot repository. Okay, so It's downloaded. Going to compile U-boot. Again, this is going to take a little bit, so I'll just pause again. But it's just compiling that specific version of U-boot that was mentioned in the one article. Now, where we go? Document? No. Here we go. Again, this was one of the keys to me, because I was running into U-boot or OpenSPI or the kernel panicking. I can't remember which, but the key was getting a specific version of U-boot and building that. That was the key to making my QEMU work. So again, I'm going to pause it. U-boot takes a while to compile. And I lied. It is already compiling OpenSPI. All right. So now we're ready to try to boot U-boot. And here we go. There we go. We're into U-boot. And we're going to pick the regular kernel to boot. And here we are. We are booting the RISC-V Ubuntu kernel. And now we get into to how slow this really is, because emulating a slow processor in software on a slow machine is really slow. I'll pause it here for a second and just let it continue to boot. So, pretty close to the end of the boot sequence. Starting up SSH, but I'm just going to log right in on the console. As it comes, as the RISC-V Ubuntu image comes, there is no graphical user interface. It's just a pure TTY interface. I haven't tried yet to install any kind of graphical user interface. I think it'll work. Gonna have to give it more memory. I think it'll be very slow. And I may run it on a faster machine in order to test the graphical user interface. The other piece I'm not real sure about is if I'm going to have any problems getting the SPICE server and VirtIO up. I have no idea if the VirtIO drivers are supported in this version of Ubuntu on RISC-V. There we go. All right, so the login is Ubuntu. The password is Ubuntu. As soon as it gets in, it's going to ask us to change that. User. You can tell Cloud Init's still coming up a little bit. So here we are logging in. All right. And here we have a RISC-V emulated environment. So it identifies itself as a 64-bit RISC CPU. So that's pretty happy. All right, so I'm going to end this, but the next things I'll do is I will, just like I did the host environment, I will apt update, apt upgrade, apt auto remove, and then I will start installing some some development tools. But this is how you can have a QEMU RISC-V emulation of the unmatched board under Ubuntu. And that's all.